All right, question 1, year 2019. Okay, so the graph shows you 3 buildings A, C, and B with connecting walkways represented by the H. Okay, so why is the graph planar? Okay, so we know that a planar graph is basically a graph that you can redraw so that no edge crosses over each other, right? So that's why the graph is planar. Then you just say, oops, sorry for that. Okay, so you can just say that no two edges cross. All right, so show that the graph satisfy Euler's formula. So this is a graph that already draw to shown planar, okay, which means when you try to look at the graph, it's already no two edges crosses. So that's why I can straight away apply your Euler's formula here. So same thing, every time write down your V, write down your F, write down your E. So V, 1, 2, 3, you have 3 vertices. Faces inside got 2, outside 1, so total 3. Number of edges, 1 for the loop, then 1 for the loop, 1, 2, 3, 4. Okay, so that's why total 4 edges. Okay, so now we try to fit into the Euler's formula. V plus F minus E equal to 3 plus 3 minus 4. And you can see that you get 2. So this is how you shown Euler's formula, like you verify. Okay, construct the adjacency matrix for the graph. Okay, so this is a very straightforward question as well. So you have 3 vertices. So that's why for your adjacency matrix, you need to write down A, B, C first. Okay, so A, B, C. All right, so from the graph itself, you can see that the loop is at A. So that's why that's one way that you can move from A to A. Then after that, A to B got 1, A to C also 1. Okay, then after that, we move on for B. Okay, so you can see that B to A, you already have 1 there. So that's why remember that it's the same thing. So 1. Okay, so B to B, there's no loop. So that's why 0. B to C got 1 also. C can go to A, C can go to B, but C cannot go back to itself. So that's why you have 1, 1, 0. So that's your adjacency matrix. Okay. So you are able to write down the correct entry for A to A, you get 1 mark. All the remainder, you get 1 mark. So being able to label all your ABC, then you get 1 mark. Okay, so that's part C. So a student wishes to carry out a close walk of length 2 from building A. List all his possible walk. So remember that it must be length 2 and is a close walk. So which means that you need to go back to A. Okay. So in this case, when you try to look at A, so I mean, of course, you can, if you got extra time during your exams, you can always try to work out like m squared to check out how many length 2 walks that is available from A to A. Okay, but under the situation that you are not compulsory to work out for the matrix, then you can also look at the graph lah. Okay, so which means that the first one that you'll be having is that we can go through the loop, right? So that's why 1, 1. So that's why A can be 1. Then after that, you can go from A to B, then go back to A. That's second. You can go from A to C, then go back to A as well. Okay, so that's the only 3 that you can do for a close walk if let's say you want to use length 2. So that's why the possible walks are AAA, ABA, and also ACA. Okay, so successfully to get 2 of the walks, you get 1 mark. Get all the 3, then you get your second mark. Okay, so which means this is how the 2 marks is given for this question. Okay, so that's it for this question.